I think the first step is actually going back, where can we do this research? Who are the people who are trained to do this research? And so far, if you think about amino acid requirements, it's only at the University of Baltimore lab that has the capability of doing amino acid requirements in dogs and cats specifically. Also, I think as we're doing training more people to do the same, I think is the first step, having trained personnel and getting these people to academia or to the industry and getting industry that support this kind of research. Hi, everyone. Welcome to the Pet Food Science Podcast. I'm one of our hosts, Dr. Julia Pezzali. I am currently an assistant professor at Iowa State University, and today I have a pleasure of having with me Dr. Anna K. Chovler. The Pet Food Science Podcast is a platform where we talk to scientists and veterinarians that contribute to research in order to advance the pet food, nutrition, and veterinary health industries. We hope to keep you up to date with the latest research, trends, and hot topics of the industry in a light and interesting way, while also saving our time. Hi, Kate. Very nice to have you here today.
You too, Julia. And I'm really happy to join the team. We always love talking data. You and I have had 4.5 years to just talk about your data. And we already know each other quite well and know each other's topics quite well. So I'm really excited to be able to host this with you because you were formerly in my lab and now you've gone out into the world. And so I'm really excited about that. So today, Julie and I are going to talk about the need to understand the amino acid and protein composition of ingredients and final products, the digestibility and possibly bioavailability of amino acids and ingredients and final products, and what we know about amino acid requirements of the species of interest, and whether we know enough to define what we call reference proteins. We're going to talk about these things because these are important concepts for every company to consider when they're setting nutrient targets and food philosophies for whatever their final product is that they're going to sell as either a dog or cat food. So why don't we, I thought that maybe we could start by encompassing a little bit about what we're going to talk about. So first, we're going to talk about considerations in the analyses of protein amino acids. Second, we're going to talk about methods to look at the bioavailability of amino acids. And third, we're going to talk about the amino acid requirements in dogs and cats and whether we know enough to define these reference patterns for dogs and cats at different life stages and in different physiological stages. But then also, do we know enough to guide regulatory guidance? Because, of course, especially in the United States and Europe, there are pretty strict guidelines for nutrient composition. So let's get the conversation started, Julia.
Yeah, so let's talk about how do we analyze protein and amino acids? Because I think it's the first step when we are formulating, we get those values. So we need to make sure those are accurate and precise as well. And for nitrogen, it's simple and straightforward. We first started with the JDO method as the official one, but over the year, we transitioned to the nitrogen analyzer, which is much more simpler and rapid as well and safer. The JDO method was the old method, and it's still considered the gold standard by some people. We're basically going to boil that sample in a sulfuric acid at high temperatures, but that's why it's considered dangerous. And then do some titration to measure that ammonia and then measure the nitrogen content of the sample. In the nitrogen analyzer, we're going to basically combust that sample, so burn in high temperatures and measure the nitrogen. And we're assuming that every protein has 16% nitrogen and then multiplying the nitrogen content to get the good protein of that food, which has some limitations. We know that not all protein has 16% nitrogen, and there's a lot of you're going to measure some nitrogen that is not coming from protein as well. But even though we have those limitations, the crude protein analysis that we have, and they are have low variability and are straightforward. So when we get those analyses from the laboratory, we kind of are confident on our results. However, when you talk about amino acids, it's another conversation. It's important not only to know the quick protein, right, but also how much of each amino acids, because animals, they require amino acids, not quick protein per se. So when you do amino acid analysis, actually have three different analyses or digestions. In those food ingredients or pet foods, the amino acids are bound to protein. So we need to hydrolyze those amino acids to know how much content of each amino acid have those proteins. And we have three analyses. The first one is a regular hydrolysis. The second one is oxidized hydrolysis. And the third one, the alkaline. So the regular one, we're going to get most of the amino acids, with exception of methionine, cysteine, tryptophan, I think vitamine and asparagine. And then with the oxidized hydrolysis is where we get methionine and cysteine and the alkaline tryptophan. And the variability in those analyses are very high. We try to keep below 10%, but most of our tryptophan is very high. So we always must send those samples in duplicates. And if you have an extra budget, I would recommend even more samples. For research purpose, when I did my PhD of Kate, we did small analysis even in quadruplicates, just to make sure we have precise estimates or accurate estimates of those amino acids. And also, I think it's important to highlight, Kate, for when we analyze methionine and cysteine, we analyze the oxidized version of them. So when you digest them, you're gonna get cysteic acid and oxidized methionine. And so basically, then we're gonna convert those values to methionine and total cysteine. But this you should have in mind that's not gonna be the available methionine or available cysteine. So maybe if you have some processing conditions that are going to oxidize our methionine, for example, you're going to basically put in the same pool of total methionine. But I think the most important message here is that analysis of amino acids, they are very variable. Those official procedures from OAC, and they need probably some update. And I don't know if you have any thoughts on that, Kate.
Yeah, I think too, it really begs the question when you're giving advice to pet food companies as well, you have to think about what your recommendations are for analytical labs that they can approach. And it's really important to use accredited labs, especially for in-product, in-market commercial products. But what it also means is that every company needs to understand what the amino acid content of their ingredients are, because we use those amino acid contents to then formulate the food, where we put a combination of ingredients together and we try to predict what's going to happen in the final product. And so when you're thinking about that too, all the companies have an obligation to do amino acid analysis on the final product, but you must be doing your amino acid analysis at the same lab, because the other component of this is that there's a lot of variability among labs. So we're talking about variability when it's the same person that's prepping the samples. You're running it on the same amino acid analyzer. Consistently, you can still see 10% variation. Now you add someone else running it, or a slightly different method that you're using to analyze the amino acids, and you've just added even more variability. So that consistency of going to the same lab, a lab that really understands the level of precision of their analytical technique. And of course, precision means that you want very good precision means that between every run that you have a really good consistency, versus accuracy, where what you're measuring is what you know to be true. And I think that's where we're going to see a lot of advancements, is in this next set of analytical techniques that we see coming to the food industry in particular. You were talking about these hydrolysis that we have to do to measure amino acids right now. But if we move to non-destructive methods in the future, I think that'll really add to our understanding of the nutrient composition as it surrounds nitrogenous compounds in foods. So analyticals continue to be a bit of a problem. But that also means that when we think about transitioning it into the next part of our discussion about protein and amino acids is we need to know what's in the food or the ingredient, but we also need to know how much of that food the animal can digest, and then the amount of the amino acids and the nitrogenous compounds that the animal can absorb. And then after absorption, those amino acids have to get to the site of protein synthesis to be able to support protein synthesis. So let's talk a little bit about those methodologies as well, and maybe we'll talk about digestibility, which the industry tends to do quite a bit. And so I think first and foremost to point out about protein and amino acids is that the majority of protein and amino acids, the vast majority, is digested and absorbed prior to the end of the small intestine and before the large intestine and all the bacteria that resides in the small intestine or in the large intestine, and how it kind of transforms amino acids. So to define protein quality or to define amino acid digestibility in particular, we have to use ileal cannulated animals if we're going to do in vivo studies. And so I think it's crucially important to point out to people that total tract amino acid digestibility is useless. And Dr. George Fahey's lab showed this years ago. If I recall correctly, it was some data from Sean Murray, where he compared ileal cannulated dogs, and they did ileal digestibility of the amino acids versus total tract. And you can detect differences of digestibility at the small intestine. And when you look at total tract, those are masked. So that just emphasizes even more the importance of looking at that ileal digestibility. Now, obviously, we're not putting cannulas in the small intestine of dogs or cats. So what can we do? Well, we can use model animals. So we can use the ileal digestibility done in the swine model, and that's currently being used for human protein quality. But we can also use the sacactomized rooster, which has also been validated against dog and cat for amino acid digestibility and is available to be used. And if you're interested, you can contact the pet nutrition group at the University of Illinois. So those are the two model animals you could use. And then what we're really seeing right now is a lot of work being done on in vitro methods to do amino acid digestibility in particular. And so we're going to start to see, a lot of us use static methods for digestibility. There's also dynamic methods for amino acid digestibility, and those are getting a lot of support for further development across all species, so we can avoid using live animals. So that's all digestibility as a measure of protein and amino acid availability. And generally, digestibility is the largest component of the bioavailability of the amino acid. But if you have amino acid transformations during processing, you might miss them on a digestibility, and you'll have to pick them up on a bioavailability estimate. So I figured that this was a good opportunity for you to describe some of the, or at least one technique, the indicator amino acid oxidation technique, to measure amino acid bioavailability, but also to describe how you can damage amino acids during processing and what the industry really needs to understand about thinking about that. So do you want to elaborate on that?
Yeah, sure. Just to add some stuff on the digestibility, I think it's going to be hard for an industry to move away from that, and there are many reasons. It's kind of only one university, Illinois, they do the cystectomized roosters so far. So there are limitations on where can you run those analyses. And the cannulated pig as well is invasive, is not simple. Not many groups they do as well. So how can we understand the limitations about the parenteral tract adjustability? I think the awareness is the first step. Okay, we can for sure not measure amino acid adjustability using that technique. We get protein, so are we overestimating, and what can we do with the number? I think creating awareness is the first step, and understanding as well that those methodologies they're the good models, but they're not easy as well. So, and they're probably much more expensive than running a parenteral tract. So how can we also kind of help the industry? How can we as academics kind of spread those techniques and help to get more data as well? So I think they're for sure the great models, but it's going to be more complicated, I think, to move away completely for parenteral tract to those models. And they are validated against the dog, right? But the cat, we assume they are, but they are not. And it's going to be very hard to validate because you're not going to be able to cannulate a cat. So it's another complication. So maybe you need to move with ferrets. And again, ferrets are very aggressive animals, so it's not easy also to keep those animals that are lab animals. So there's a lot of limitations. And moving away from one methodology has been used for the years is hard. But I think creating awareness, as you said, is not it doesn't tell us much, but with what is telling us, how can we use it and consider the limitations for sure. I think that's the very first step for the industry to understand. Do you have anything else to add for the disability case, or?
No, I guess maybe the only thing to maybe think about there too is if we are giving, when companies look at total tract digestibility, I think it's really important to know that, maybe your protein number gives you a little bit of a better indication, but the amino acid digestibility total tract are not valuable, really. So protein better apparent total tract, but don't look at those amino acid digestibilities because they won't tell you much.
Yeah. Well, maybe over the years we have so much data on a parenteral tract, we can maybe do some meta-analysis or models too. When you get more data, we get the mice and try to understand it better. Maybe.
Wow. I mean, we could largely say that we probably have the data that we can start to model some of that, because the black box in there too is really understanding how changes in the hindgut microbiome affect both the use of nitrogenous compounds, but also the production of nitrogenous compounds as free amino acids and nitrogen compounds, but then also bacterial protein, right? Yep. So we have so much more to learn, and that hindgut isn't inert when it comes to protein either, right? We kind of put those blinders on a little bit, but as an example, in the side kind of side caveat here is that anything that does flow into the colon is going to be utilized by bacteria in some ways to produce some beneficial compounds, but potentially to produce deleterious compounds too, such as putrefactive compounds from protein fermentation. So we have a lot more to learn and a lot more to understand about that symbiotic relationship that we have with those bacteria that are in our gut.
Yeah, I think the issue as well, many people think maybe for cats are carnivores, so there is nothing going on in the large intestine, but there is. So people need to keep that in mind, and it's important also to consider not only for pigs but I think let's talk about bioavailability. And we talk a little bit of the unique amino acid oxidation with our other host, Dennis, during our first talk. And we talk about using the methodology to determine amino acid requirements. But as Kate mentioned, you can also use the same methodology to determine the bioavailability of amino acids. And that brings value because even when we apply those cystectomized rooster models or the ileocannulated pig, there's some amino acids that are going to be modified chemically, but they're going to be absorbed and are going to be able to utilize for protein synthesis. So they're going to show up as digestible or absorbed, but they're not going to be utilized. So that's when you talk about bioavailability, the amount of amino acids that's going to be absorbed and utilized for metabolic reactions. And the classic example is lysine. During processing, you may have Maillard reaction. So the lysine is the most common one attacked by the sugar compounds because it's two amino groups, so it's more um, say vulnerable. And that's my cat. I knew that would happen at some point. Anyways, the lysine is more susceptible to those um, reactions because it has two amino groups and it's going to be absorbed but not utilized for protein synthesis. So we are going to, when you get the results for those animal models, it's going to show up as um, disappearing from the small intestine, but it's not going to be utilized. And when applying the amino acid oxidation technique, we are investigating how much of the amino acids being utilized for protein synthesis. And the same way, you're going to do we're going to give a labeled amino acid, which is 13-cyclin-guanine, and you're going to measure its oxidation by measuring the flux of 13-CO2 in the breath of the animals. So basically measuring the end product of the oxidation of the amino acid, which means its utilization by the animal. And to use the IO technique to measure bioavailability, it would basically going to use a basal diet that we know our limiting amino acid is 100% bioavailable. So let's say we're going to measure the bioavailability of poultry meal. We first need to know, compared to a basal diet, that we know the availability of the limiting amino acid. And I'm saying the limiting amino acid because we can only measure the bioavailability of one amino acid at a time, the limiting amino acid. So that's one disadvantage of the IAO. We only get the bioavailability of one amino acid. And then we kind of assume that all the other ones are going to have similar bioavailability, but may not be true. But we're going to compare, let's say, the limited amino acid on poultry meal is methionine. So we're going to compare to a basal diet that you're going to provide this amino acid or methionine as a synthetic source that we know is 100% bioavailable. Then I want to feed at least three levels of that diet with the methionine concentration below the requirement. So maybe 60% of the methionine requirement, 70 and 80, a little bit higher, but I'm just making up some numbers here. And then feeding a diet with methionine supplied only from our test ingredient, which is in this case, let's say, is poultry meal. So I want to have 6% of the methionine coming from poultry meal, 70%, 80%. And then I want to compare the slope after the regression against the basal diet. And basically the same principle, the higher, if you increase the requirement, you're going to decrease the oxidation because more of the marker and consequently of the limited amino acids going to protein synthesis. And then we compare the slope of the basal diet compared to the our test ingredient. And usually the lower the bioavailability, you're going to see like this slope's going to be lower or like increase, going to more be my straight line and more close to 100% bioavailable, very close to our basal diet. So that's a way to measure bioavailability. I have an idea about how much of those amino acids are being utilized by the animal. And I think that's very important for lysine, as I mentioned, because we do a lot of processing techniques that destroy or make lysine unavailable. But there are also the amino acids that we don't look much, such as methionine. There's a lot of oxidation of methionine during processing that we don't take into consideration. It's also hard to measure. But that's one methodology to that we can measure bioavailability.
Yeah, so maybe revisiting to looking at this, we're talking about measuring bioavailability in the animal of an ingredient or a complete food. But is there anything, do you want to expand a little bit on things that you can measure in the food that might give you an indication of the bioavailability of, I think that lysine is probably being examined the most?
Yeah, usually the what people do the most is the reactive lysine. And if it's reacting, it's because it's bioavailable. So the ratio about lysine to reactive lysine, the opposite is what people use the most as a kind of understand the heat damage, how much the heat damage is destroying those amino acids. So that's a great indication, and I think it's a great start as well. And it's not very expensive. It's much cheaper than doing an indicator amino acid oxidation study, for sure.
And two, I think this is an important caveat because we have really differently processed foods on the market. And yet we draw people's attention to the ingredient deck. So when you look at something like chicken, is it just a standard bioavailability? Do you want to kind of to help the listeners understand how you can really bugger up an ingredient with different processing?
Yeah, and I think when you think about processing, we start with the processing that we apply in the raw material. So raw material quality is the first step to ensure final quality of our product. And when we have, for example, poultry byproduct meal, although we have one definition established by AFPO, there are different ways to produce the poultry byproduct meal. So how much heat are we going to use to produce? And the byproduct are basically trying to create a concentrate source of protein. So we're going to remove the fat, remove the moisture as much as we can. And to do that process, we apply heat. And heat, although is our best friend to kill pathogens, is our enemy for nutrients. So something can be good and bad at the same time as everything in life, and heat's the same. It's great to provide food safety, but for a nutrient perspective, you're going to decrease the bioavailability of many amino acids. So I think the first time we need to understand the quality of our raw material. So when you get a poultry meal, not all poultry meals going to be the same. There's going to be a huge variability between where you source this protein meal, and we're seeing batches as well. So we need to make sure that we are sourcing for a specific manufacturer, and they have a low variability in between samples. And many companies, when they get ingredients, they have a lab analysis that they do those analysis, but also maybe you should also measuring not only amino acid concentration in those ingredients, but also the ratio of reactive lysine to lysine, for example, to give us a better indication about how aggressive is the rendering process that they're applying. And that's going to be a very important consideration. When we move to the mechanically separated meat, which is just show up as, for example, chicken or beef in our package, when you talk about extrusion or even canning, those are going to be raw, and they're going to be included in the process as raw meat. So those are going to be, in theory, high protein quality. But at the same time, they're high in fat. They're better source of fat and moisture than protein. So they're not concentrated. So if you consider the amount of protein for protein quality, that's also going to have decrease the protein quality a little bit, because not a good source of protein anyways. So people have to understand those concepts as well. But yeah, I think the first thing that we think about processing is processing applied to the raw material. We're going to have some losses of amino acids, and it's all about heat exposure, so the temperature and the degree. So the degree of heat exposure, like the temperature and the amount of heat exposure. So for how long are we applying the heat? So those are the two major factors that we need to consider. And that applies for extrusion and also for canning. So for extrusion, many people think that we're going to have a lot of amino acid losses during the extrusion process, but actually those occur also during drying. So during drying is where you're going to see the most loss of vitamins and also the maillard reaction occurring. So we need to give better attention to our drying process. And we focus again on food safety. So remove all the moisture to keep the product safe and don't have any growth pathogens of growing mold and so on. But also the more heat you apply, the more amino acids are being lost as well. So we need to consider that. And for canning, the commercial sterilization process that currently utilize the pet food industry, you have an F value much higher than is necessary. So we're over processing everything. So how can we kind of optimize these conditions to make sure we're producing a safe product, but also we're not destroying as many amino acids or nutrients during this process?
Yeah. And I think too, that, we can't forget that probably one of the biggest reasons that we cook a food after the stability and the microbial safety aspect is we need to cook the starch. Dogs and cats don't handle uncooked starch very well. And so we also look at aspects of starch cook, and we know that the better that you cook the starch, the more digestible it is. So this conversation just really emphasizes that when we're thinking about amino acid and protein analyticals, and we're thinking about the digestibility and bioavailability of the amino acids, that companies really need to understand their ingredients and at minimum how those ingredients with the level of digestibility are. And it's really important to also do if you're considering a process change in for your pet food. So if you're thinking about, like you said, changing the temperature that you extrude at, or the duration of the extrusion process. So just to really implore those companies that are thinking about these stages to remember, you should always, if you're going to change part of your process, you should come back to make sure that you haven't altered any of your nutrient dynamics for that formulation. And I don't know if people always think about that. So I just wanted to emphasize that as well. So kind of moving along, really the third component of protein quality, and we're not going to talk about this to a super great extent, but is the amino acid requirements. And for anybody who's listening that hasn't listened to either when I was the guest or when Julia was the guest with Dr. Dennis Jewell, is we both talked about the lack of information that we have on amino acid requirements in dogs and cats. There's very little in dogs, and there's even less in cats. And this isn't about deficiency in surfeit. It's about the empirical measurement of an amino acid requirement. We've got some ideas about that, but we also have very little idea about how an immune challenge might change an amino acid requirement. We know very little about how amino acid requirements might change going into the senior and the geriatric phases of animals. And I think what's really important to maybe share broadly with the listener is that all proteins aren't all proteins. So you have really well-balanced proteins. We tend to think of milk-based products and egg-based products as those, but it should look like the amino acid requirements of the animal. And so to really have a good understanding of that, we do need these measures. But what really, one of the things that I wanted to talk about and see, Julia, how you felt exposed to this during grad school as well is that there's nothing that I loathe more than the regulatory second part of the claim of complete and balanced. There's so little in the regulations that have to do with balance. And so companies really need to look at where their amino acids are and how much greater, because we do, first of all, believe, I think from both of our podcasts, it was clear that we both firmly believe that the amino acid requirements are underestimated right now, and dogs and cats might likely need more. But the amino acid balance, so the ratio of all the indispensable amino acids, the ratio of the indispensable amino acids to the total dispensable amino acids, we know very little about this in the dog and cat. And those amino acids the pattern of those amino acids may be different for different physiological stages and life stages. So that's going to be really, really important as we kind of look to what our guidance is in terms of amino acid targets. But when you think about ideal proteins, Julia, what guidance would you give the industry about how to think about that in total when they're formulating complete diets?
Yeah, no, I think it's a tricky question as well. And just before we move to that, I think to people understand when you say empirical determination of amino acids is not only feeding a diet that has some specific concentration of amino acid for 2 years, okay, they're healthy, so that's their requirement, is providing graded levels of the amino acid until we find a break point or no changes in a biological response. So I think people have a hard time sometimes understanding that's empirical determination, or the industry sometimes. Those is all feeding a diet and make sure they're healthy. Probably, okay, they're healthy because they're oversupplying everything, but what is the ideal amino acid to support a specific biological response? And I think the ideal protein is probably not coming from one protein source unless you're eating a specific part of our muscle, because that's the ideal protein for each species. But I think balance is very important. Having different protein sources to provide those amino acids, the ideal balance of amino acids is the first step that we need to look into. I know specific diets or specific formulations are going to see for only one protein source for specific reasons, but I think variety is very important to meet those different amino acid ratios and composition. I think we also have a lack of, we are asking for the industry, okay, let's balance the amino acid profile. But what is the ideal balance? We don't know exactly, as I said, we don't know much yet, or where can they find this information? They know for calcium, phosphorus, for sure, but okay, how about amino acids? What is the ideal ratio? We may know for a little bit tryptophan to large neutral amino acids based on the NRC ratios, but how about the other amino acids? What is the ideal ratio? Which one should not be much higher than the other? So I think we also need those amino acid requirement studies to derive that ideal balance and then go from there. Because I also sometimes ask myself, where is this information? So it's kind of hard to ask for results, but also we don't know the answer. So I think we need a lot of collaboration between academia and industry to get this data out and provide better formulations for ideal or really balanced diets, as you mentioned, that we are still lacking.
Yeah, so maybe, and I haven't talked to you about this, so this will it's coming out of nowhere. But now that you're on the other side, and you're now responsible as a faculty member for not only teaching but doing a certain amount of research. Dennis and I talked a little bit during my podcast about where we get money to do that and what kind of work that facilitates. But you're a brand new professor. You're out looking for those opportunities now. And if you could tell the industry what would look like a great way to advance our basic understanding of dog and cat physiology, what are your thoughts?
I think the first step is actually going back, where can we do this research? Who are the people who are trained to do this research? And so far, if you think about amino acid requirements, it's only at the University of Baltimore lab that has the capability of doing amino acid requirements in dogs and cats, specifically. Also, I think as we're doing training more people to do the same, I think is the first step, having trained personnel and getting these people to academia or to the industry, and getting industry that support this kind of research. Can we buy this equipment? Can we run those trials? And can we precisely provide those estimates? So I think the first step is what you're doing, training people. I think that's the first and very important step, and getting the industry to understand that those trials are expensive. They are not easy. They require a lot of effort and teamwork, but they are worth it. And when you think about formulated diets, think about health and longevity and well-being, we need to think about requirements. It's so basic, but we don't look at it. We are looking at the other side of the equation, health claims and all those different gut health, all those, every kind of health. But how about the minimum amount of nutrients that they need? So I think it's very important to go back, take a step back, understand that. And unfortunately, in the US, we don't have much support from government funding from pet food research. So we rely a lot on the industry to get this data going on. And so I hope that over the years, the industry can understand that to support the health and well-being claim that every pet parent wants to see, we need to understand amino acid requirements. So I hope that's something that create awareness over the years and make the industry kind of go back to support basic research, not only applied research with, I think the basic research is the fundamental or the base of applied research.
Yeah. Yeah, I would love to, and I don't know how to go about it, or maybe it's the Pet Food Institute's responsibility to kind of go about it. I would love all the pet food companies to target some things about metabolism that would benefit everyone knowing about, and so have strategic research questions and put money towards it. And maybe it's based on their, net outside sales or something like that, that every year they have X amount that they give back to research. I think I would love to see the pet food industry move something like that. So maybe I can plug us getting a little bit more agnostic funding sources rather than really targeted requests, which I think a lot of us get in research. Sorry, go ahead.
And the commodity associations, I think like the farmers for specific grains, they do that. They have those checkoff associations. Yeah, everyone put money to, okay, let's advance research. So maybe in the pet food industry, and they're competing as well, they're farmers, but they all want to, get profit out of it. So maybe in the pet food industry, we should think, as I said, about something similar to everyone puts a little bit of money to answer a question that's going to benefit everyone. And at the end of the day, should be benefiting the animals. So if you have those claims if your company wants to provide about the best diet for the pets, we should think about more as a collective, in a collective way rather than just profit. But I think we are moving towards that. Hopefully,
Yeah, I think so too. I think in general that there is interest. Everything's moving. It is a consumer good, so there's good and bad about them all. So maybe to wrap it up. Previously, I know I think Dennis asked me about favorite book. But I thought that I would kind of switch it out at the end of the podcast and ask you, because I don't know this and I doubt you know mine either, but what's your favorite movie that revolves around an animal?
Oh my God, that's gonna sound weird, but I don't watch much movies anymore. I don't even remember.
Okay, what about TV show?
I don't watch TV shows either. That's even weirder. Like,
this is how you get so much done. You don't watch any TV.
I like to watch cooking TV shows like MasterChef or any baking competition, which I don't like cooking either. So it doesn't even make sense. But I think then one movie that I cried a lot was like oh my God, what's the name? They have a Labrador. Marley? No.
Yeah.
You know what I'm talking about.
Yeah. Now I'm blanking. Was it called Me and Marley?
I think so, yeah. I think everyone who loves animals was kind of like touched by that movie. And for me, it was like, I was very touched as well. When I was a kid, I loved that Baby, because I love pigs as well.
Oh, so, Babe, yeah.
Yeah, so it's just like those, I don't know. I'm not a movie person, but I like anything that involves animals.
Babe,
how about you?
Yeah, I'm surprised you didn't. I think hands down, my most favorite companion. I'll use a companion animal character, Puss in Boots, and from Shrek.
Yeah,
I think he's quite outstanding and seriously hilarious. The TV show is also very hilarious. The spin-offs where there's a spin-off with a bunch of kittens that are really rascally and he has to like kind of mentor them is pretty hilarious.
And a try.
Oh, you have to. It's very, 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 very funny. So that'd probably be my favorite movie / TV. And then last but not least, I thought it would be interesting to have you tell me one thing I failed to tell you before you moved on to a faculty position that I should have while you were my PhD student.
I'm gonna have this public conversation in public. That's tricky as recording. Just kidding. I think I'm also new as well. Like I've been in this position for not a long time, so I'm still learning a lot. And I think nobody teaches you how to navigate through politics or you only learn when you jump in. And I think there's different ways to navigate through different universities as well. What I think you need, maybe, I thought I was independent, but you need a much higher level of independence when you go to a faculty position. And yeah, I think that's something maybe you didn't advise me right away. But I, of course, have mentors, but you need a much higher level of independence. And maybe I'm moving straight from PhD to a faculty position, and then you have to make a switch in your head very quick as well, and kind of have a level of maturity and very in a short time. So I think it's challenging, but also I love research. I love teaching as well. And I think having this in mind always keeps me going. But I think whoever wants to go to academia after a PhD is challenging. So be very independent and try to be independent during your PhD as well, because everyone tells you have to be independent, but it requires a very high level of independence because you have a boss, but you're mainly your own boss. So how you're gonna not set up yourself for failure? I think that's the very most important thing. How we're gonna organize our schedule, because nobody's gonna be checking on you. So how can you deal with that? So I think that's the most important part. And we learn by doing, but you should be learning how to do this during your PhD program. And I think I did, but it requires a much higher level of self-discipline, I would say.
Yeah. Well, to be fair, you were also an extremely independent PhD student. So I didn't really target. You were very independent already. So how far can I take you? But you're right. Independence, and then I think maybe part of that is having a thick skin to be confident enough to be independent.
Yeah. We have to, I think, trust ourselves. I think we have all this imposter syndrome sometimes, and you need to trust yourself and know your value. I think that's a very important part for young people when you go to the market. You're young and you're recent hire, but if you are there, it's because you're bringing value. So know your value and know your boundaries as well. I think that's very important, regardless what kind of job you go to. Know your value and stay up to it.
Yeah, absolutely. Well, Julia, it was a pleasure to be your advisor, and it's most certainly a pleasure to have this continuing academic relationship with you. And I'm so excited about co-hosting this with you. And thanks very much for having this conversation with me today.
Yeah, no, thank you, Ben. I'm very excited as well to keep talking to you. So you thought you were going to get rid of me probably after I graduated, but here I am, I guess.
No, you warned me. You warned me about Brazilians. I think I know.
Yeah, once you have one Brazilian, you're gonna, you open the door. Now we're gonna have a Brazilian master coming to your lab probably. So I hope they're good. No, you're good. Well, yeah, it's gonna be great to have you on this podcast as well. It's gonna be. I hope we have plans. I think that's gonna be a very nice way to talk with people and share information.
Yeah, and I think this is probably a great way to end off. Is for anybody that's attending the annual Society of Animal Science in Albuquerque this month. Julia will be speaking in both the companion animal and in another section that's simultaneous to the companion animal on amino acids and protein metabolism. So please go and support her there and continue to learn more about amino acids and protein metabolism from her. So with that, thanks very much. And I'll see everybody shortly.